Students, on lesson 6.6, we are going to be working with subtraction and renaming numbers. So our essential question at the top of the page is, how can you use renaming to find the difference in two mixed numbers? So we're going to start here on the side, because we want to make sure that when we're reading the problem, we're able to get important information from the problem. So first it says, underline the sentence that tells you what you need to find. And secondly, it says, what operation should you use to solve the problem? So we're going to start here at the real world to unlock the problem. To practice for a race, Kara is running 2.5 miles. When she reaches the end of her street, she knows that she has already run 1 5/6 miles. How many miles does Kara have left to run? So boys and girls, we are going to underline how many miles does Kara have left to run, because that's what we need to find. And when we hear the words, boys and girls, in here, left, we have to think subtraction. So that's the operation that we're going to need to use to solve this problem. So one way, boys and girls, that we can do that is we can rename first the mixed number. So again, something that's going to stream its way through is we're going to estimate. So when you estimate, boys and girls, we're rounding to our benchmarks of 0, half, and 1. So what we do, boys and girls, is we estimate and we see that 2.5 is pretty close to 2.5. And then we say 5/6 is really close to 6/6, so that would be rounded to 1 whole. So we would say that 1 whole that we round 5/6 to, plus the original 1 would be 2. So we're subtracting by 2. So we think about that. We have 2.5 minus 2. We have a half left over. So when we get to our final answer, boys and girls, we want to make sure that it's close to our estimate of a half, because then we know our answer is reasonable. Step 2 says find a common denominator. Use the common denominator to write equivalent fractions with like denominators. So again, boys and girls, something that we worked a lot on last week is that when we find common denominators, we want to find the least common denominator. And although we can multiply both denominators together, 2 times 6 is equal to 12, we know that that necessarily isn't the least common denominator. So what we want to do is we want to list multiples. So boys and girls, we're going to list multiples of 2 and of 6. And again, the reason why we list multiples is because then we can find the least common denominator, which we can use to rewrite equivalent fractions. So the first couple multiples of 2 are 2, 4, 6. And we can stop right now at there because we know the first multiple of 6 is 6. And remember, multiples are 2 times 1 is 2, 2 times 2 is 4, and 2 times 3 is 6. 6 times 1 is 6. So multiples are the answers in multiplication problems. So we see that 6 is a common denominator. So what we're going to do is we are going to use that to help us. Our common denominator is 6, which we can write on the side. And it says step 3 is we're going to rename 2 and 6/12 as a mixed number with a fraction greater than 1. So you might say, well, how did we get there? So just keep in mind, boys and girls, we multiplied 2 by 6, and we multiplied 1 by 6, so we got the answer of 2 and 6/12. And again, we multiplied 6 by 2, and we multiplied 5 by 2, because remember, boys and girls, when we write equivalent fractions, the numerator and the denominator have to be multiplied by the same number, because remember, either 6 over 6 or 2 over 2, all those represent 1 whole in fraction form, and these are just equivalent forms. They're not bigger, they're not smaller, they are equal. So what we're going to do is we're going to rename 2 and 6/12 as a mixed number with a fraction greater than 1. So what we think to ourselves, boys and girls, is we can break apart 2 and 6/12 to be 1 plus 1. And where I got the 1 plus the 1 was from the 2. And then we can say plus the 6/12. But now if we wanted to trade one of those 1s, we know that 12/12 is the same as saying one of those 1s, because 12 divided by 12 is equal to 1. So if we rewrite that 12/12 again, now what we can do, boys and girls, is we can add up our mixed number. So we get 18 twelfths because we did 6 twelfths plus 12 twelfths, and we got 18 twelfths. And then there was our original 1, which is also in our final answer. So we got 1 and 18 twelfths. So now, boys and girls, what we're going to do is we're going to go back up to our regular problem, and we have our answer, which is our fraction with a denominator that is greater than 1, 18 twelfths. So now, boys and girls, we do 1, again, the whole numbers together, a 1 minus 1 is 0. And then, boys and girls, we can just simply subtract our fractions. 18 twelfths minus 10 twelfths would give us 8 twelfths. Now, 8 twelfths is not in simplest form, boys and girls, because a common factor in both of those would be 2. So we think to ourselves, well, what number times 4 is equal to 8? And that would be 2. And we think to ourselves, what number times 4 is equal to 12? And the answer would be 2/3. So the trickiest part, boys and girls, about this is renaming. And this is the only thing that we're doing new in this lesson compared to the previous lesson. Also, I'll break down a couple problems like this at the end just to give you a little bit of extra practice and support with that. So step 4 in this problem, it says find the difference of the fractions and then find the difference of the whole numbers and write your answer in simplest form and check to make sure that our answer is reasonable. So we knew that our answer was 2/3 of a mile left to run. And then it says explain why it is important to write equivalent fractions before renaming. So boys and girls, something we can say is it is important to write equivalent fractions first to decide if renaming is needed. And renaming, boys and girls, is what we did in step 3. And remember, the only thing that's new today for us, boys and girls, is step 3 in the renaming. So another way, boys and girls, that we can do the same sort of problems is that we can rename both mixed numbers as fractions greater than 1. So in the next problem that we have here, it says 2.5 minus 1 5/6. So it says write equivalent fractions with a common denominator. Again, boys and girls, we want to make sure that we list our multiples, and we know from the previous problem that the least common denominator was 6, and we're going to use that to help us out when solving this problem. So we think to ourselves, well, if we multiply the top and the bottom by 6, we would get 2 and 6 twelfths. So boys and girls, I'm just going to double check what I did here in some of our work. When we see this, if we know that the common denominator, least common denominator is 6, we know that 5, 6 is in the proper form, so we can leave it at that. We want to make sure that we think to ourselves, well, what can we multiply 2 by to get 6 in the denominator? We know that number is 3. So then we come up with 2 and 3/6. Now you go on to step 2, which says rename both mixed numbers as fractions greater than 1. So we think to ourselves, in these particular fractions, we're saying, when we say one whole, it's like saying I have 6/6. Another whole would be another 6/6. And then we have our 3/6. So boys and girls, when you think about this, really you have 15/6. And you might say, how did you get that? Well, you think 6 plus 6 plus 3 is 15. Again, this one whole is really 6/6. 6/6 plus 5/6, boys and girls, gives you 11/6. So now step 3, it says find the difference of the fractions and then write your answer in simplest form. So now we have 15/6 and we have 11/6. So 15 minus 11 would give us 4/6, and we think to ourselves, well, 4 and 6 do have a common factor, and that common factor is 2. So we think to ourselves, what number times 2 equals 4? Well, that's 2. What number times 2 is equal to 6? That's 3. So our answer in simplest form would be 2/3. And now, boys and girls, if you think about this, I'm going to practice renaming a little bit more because I know that's something new, and I'm going to do it on the next page for you. Also, I suggest that you still practice estimating to check the reasonableness of your answer. So boys and girls, we have 2 fractions here. In this particular fraction, you need 3/3 to have one whole. So if we trade one of these wholes, we would have 3/3, which would be one whole. If we trade another one of these thirds, we would have plus 3/3. And then if we trade one more of these thirds, we would have another 3/3. So boys and girls, really, if we wanted to rename this fraction, this mixed number and a whole number, we'd say 3 plus 3 plus 3 is 9. Then we have plus 1 would be 10/3. And this is called an improper fraction. But, boys and girls, it is okay for this particular lesson because we're going to be subtracting these. Again, we're going to practice this strategy. If you have this fraction, you need 5/5 to get one whole. So if we trade one of those wholes, we get 5/5. And remember, 5/5 is the same as 1. And then if we trade the other one of those wholes, we would get another 5/5. Because remember, 5 divided by 5 is 1. 5 divided by 5 is 1. 1 plus 1 is 2. And then we have our original fraction, which is 4/5. So we would have 5 plus 5 is 10, plus 4 is 14. So our improper fraction here would be 14/5. It's really important to estimate, boys and girls, with these problems because you want to make sure that renaming is necessary. But if you practice just writing some mixed numbers and renaming them, it might help you a little bit with this lesson.